Hello everyone and welcome to another episode on this very channel. In these very tutorials, we shall be looking at the addition law of probability. If you have not subscribed to my channel, kindly subscribe for me. When we talk about the addition law of probability, then what we are saying is that if A and B are events from the same experiment, if A and B are events from the same experiment, then the probability of A or B happening, then the probability of A or B happening, which is the same as probability of A union B, is giving us probability of A plus probability of B minus probability of A intersection B. So this is what we refer to as the general addition law. So we have the general addition law. We can also use the Venn diagram to illustrate this law. So we have our A, we have our B. Since we are having an intersection, these two circles are going to intersect. So this region is going to represent what? The intersection. Now, however, if A and B are mutually exclusive events, then it means that event A and event B do not have anything in common. In other words, event A and event B cannot happen at the same time. An example of a mutually exclusive event is the flipping of a coin. We know that when we flip or toss a coin, it is either we get a head or what? A tail, but not head and tail at the same time. You can attest to the fact that when we flip a coin, we can get only a head at a time or a tail at a time, but not head and tail at the same time. Therefore, the event of having a head or tail are mutually exclusive events. So what we are saying that if events A and B are mutually exclusive events, then event A and B have nothing in common, and therefore this intersection will become 0. Then the addition law becomes probability of having A plus probability of having what? B. So if the two events, which is A and B, are mutually exclusive events, then the addition law becomes this. So with the addition law, we'll be making use of this word or, and then this symbol U. So the or and the U means the same thing, and it corresponds to the addition operation. So kindly take a note of this. We'll be making use of it frequently. The or, the union, it corresponds to the addition law. So let's look at some few examples of the addition law. So given that P of X is 0.35, P of Y is 0.45, and P of X intersection Y is 0.2, we want to find the probability of having X union Y. So we have our solution. Probability of having X union Y. We have probability of X plus the probability of y minus probability of what? P x intersection y. So P of x we have 0.35, P of y we have 0.45 minus P of x intersection y. Since it is given, we have to make use of that. So when you add all of this, you are going to get 0.6. So the probability of having x union y is equal to 0.6. Let's look at another example. So if two events x and y are mutually exclusive events, if events x and y they are mutually exclusive, and then P of x is 1 over 3, P of y is 2 over 5, we want to find P of x intersection y. So as we have already discussed, if the two events given are mutually exclusive, then they have nothing in common, and therefore their intersection will be equal to 0. So you can say that probability of x intersection y is equal to 0 since the two events are mutually exclusive events. Then you want to find II, P of x union y. Since the two events are mutually exclusive, then their intersection is going to be 0. So the addition law becomes P of x plus P of what? Y. P of x we have 1 over 3. P of y we have 2 over 5. Now when you do the addition, you are going to have 11 all over 15. As easy as that. Let's look at another example. A bag contains 40 marbles, 18 of them are blue, 14 red, and then 8 green. What is the probability that a marble selected at random from the bag is either blue or green? Very, very easy. Either blue or green. So the keyword is either blue or green. So let's start. So let's use B to stand for blue balls, and then G to stand for what? Green balls. Number of blue balls. How many number of blue balls do we have? We have 18 of them are blue, so we have 18. Then we have number of green balls. How many green balls do we have? We have 8 being green, so we have 8. Then number of marbles in the back, which is the sample space, we have how many? We have 40 balls. Now we are looking for blue or green. So we have probability of having blue or green. So we have probability of having blue or green. The keyword is what? Or, which refers to the addition law. Now looking at this experiment, we can say that this experiment is a mutually exclusive event because we can't pick a marble from the bag with different colors. It is either going to be a red color, a green color, or a blue color, but not a mixed color. So picking a marble from the bag is a mutually exclusive event. In that case, we are going to use this addition law. Probability of picking a blue ball plus probability of picking what? A green ball. Very, very easy, and as easy as ABC. So we have to first find probability of picking a blue marble from the bag. So we have probability of picking a blue marble from the bag, and it is giving us number of blue balls all over the number of outcomes in the sample space, which is the total marbles in the bag. Number of blue balls we have 18 all over total marbles in the bag we have 40. Then we also need to find the probability of picking a green marble from the back. So we have probability of picking a green marble from the back will also be giving us number of green marbles in the back all over the total number of marbles in the back. Number of green marbles we have 8 all over 40. So once we have this, we are just going to substitute this in place of that. So we have probability of picking a blue or green marble is equal to P of B. P of B we had 18 all over 40 plus P of G. P of G we had 8 all over what? 40. Now all what we have to do is to just simplify. 18 plus 8 will give us what? 26 all over what? 40. So this is going to give you 13 all over 20, as easy as that. So this brings us to the end of today's lesson. See you tomorrow. Bye bye.